All right, let's look at example 3b. Now, when we want to add these two expressions together, we have a rational expression plus we just have a whole number. And so what we can do is put the whole number, just write it over 1, plus 3 over x minus 1. So in this problem, the LCD is a little clearer to see. It's literally just the x minus 1. So what I need to do here is just multiply the numerator and the denominator by x minus 1, and I'll distribute the 4. So I get 4x minus 4 all over x minus 1 plus 3 over x minus 1. Combining like terms, I'm going to get 4x minus 1 all over x minus 1. And so the tempting thing to do here is cancel the 1's. Again, you're not allowed to cancel terms because technically the 4x minus 1 and the x minus 1 are really, they're held together by that minus sign as one binomial factor, or each one is a binomial factor. You cannot cancel a term. Let's look at two more examples. First one here is a subtraction problem. And what I'd like you to do before you even start to build, factor and build the fractions to have a common denominator, I want you to change that subtraction to an add the opposite. So we're going to make that a plus sign, and then the 2 is going to be negative. So subtracting a positive is like adding a negative. Now when you multiply by the missing factor, you're going to distribute that negative 2. Otherwise, I find students make a lot of errors when they just leave that minus sign and try and deal with it later. All right, we're going to follow the instructions for finding an LCD. We're going to factor each denominator. This is x minus 3 times x minus 4. Can't factor the second denominator. I'm going to rewrite the fractions. This way I have a little bit more room to work with. And so my job is to find the LCD. And on this one, I'm going to do it a little bit differently. You can find the LCD and write it off to the side, or you can literally build the LCD right within the problem. In other words, I look at one denominator and say, does this denominator, is it missing anything that the other denominator has? The other denominator has an x minus 4, so I'm not missing anything that this denominator has. So now I look at the second fraction. I say, is this denominator missing anything that the other denominator has? And the answer is yes, it's missing the x minus 3. So I'm multiplying by the missing factor, and instead of writing my LCD off to the side, I've really just created it within the problem. I now need to distribute the negative 2. Now that I've distributed the negative 2, I want to combine like terms. And combine it, the 2x and the negative 2x are going to cancel each other out. And so I end up with 15 over x minus 3 times x minus 4. All right, the last example is kind of what I'd call a special case. It's when the denominators are the opposite of each other. And so when you look at this, it almost looks like they have a common denominator already, but we have an x minus 5 in 1 and a 5 minus x. And we've talked about this before, that these are opposites of each other. And so to fix this, what we can do is just simply multiply the numerator and denominator of that second fraction by negative 1. And in doing that, we get x squared over x minus 5 plus a negative 4x minus 5 all over x minus 5. Right? To multiply 5 minus x by negative 1 will give you x minus 5. Now we can combine. We get x squared minus 4x minus 5 all over x minus 5. And again, you always want to try to factor and see if you can cancel any common factors. The numerator factors as x minus 5 times x plus 1 all over x minus 5, and the x minus 5's cancel, And your answer is x plus 1. All right, at this point, I have a couple of examples, again, that I'd like you to try. So if you want to practice, pause the video and then try these two problems and then start the video up to check your work. And if you just want to follow along and watch me do these two, you can do that as well. So let's start with practice 3A. All right, in this problem, we're going to, let's first rewrite the problem to give ourselves a little room to work with here. Leave a little space. So we're going to be multiplying by the missing factor. I'll list the LCD up here. And so basically, I want to start by finding the LCD of 2 and 5, which is 10. And I know I have a factor of x, and I know I have a factor of y. The highest power of x is 3. The highest power of y is 2. So that's my LCD. Now my job is going to be to build each of these fractions so that it has the LCD. And so I'm missing, for this fraction over here, I'm missing a factor of 5. And I have an x and I need an x cubed, so I'm missing a factor of x squared. And I have a y squared. Oops, LCD, there should be a 2 on the y squared. The highest power of y is y squared, so my LCD should have a y squared. So I have a y squared, I need a y squared, so there's nothing missing. Now on to the second fraction. I need a 10, I have a 5, so I'm going to multiply by 2 over 2. I have an x cubed and I need an x cubed, so I'm not missing anything there. Here I have a y and I need a y squared, so I need to multiply by y. So we'll multiply across. We've got 15, multiply our numerators here, 15x squared over 10x cubed y squared plus 8y over 10x cubed y squared. Combining like terms, I'm just going to combine the numerators. They're not like, so I will just leave them as 15x squared plus 8y all over 10x cubed y squared. Now again, in the end, you want to make sure that there's no common factor, something that you could pull out of the numerator here. There's no greatest common factor to remove, so there's nothing I can do to cancel. I can't cancel any x's because there aren't x's in each term. I can't cancel a y because there's not a y in each term. There's nothing to factor out, then there's nothing to cancel. All right, so this last one. On this one, the recommendation is to change this right away to add the opposite. All right, let's factor our denominators. So I've got 3x plus 7 over x minus 3 times x minus 2 plus a negative 3 over x minus 3. So on this one, again, you can build the LCD off to the side, or you can just literally look and say, you know, am I missing anything in one denominator that I have in the other? And I am missing an x minus 2. So I'm missing an x minus 2 over here. I'm not missing anything over here. My LCD is x minus 3 times x minus 2. I'm going to distribute. In distributing, I did both distributing and I wrote both numerators together. So I've got 3x plus 7 minus 3x plus 6. Now I'm going to combine like terms. The 3x's cancel each other out, and I end up with 13 over x minus 3 times x minus 2, and there's nothing to cancel here.